Moving to number 11 here in our test review. Find the solution of this exponential equation, 17 e to the x minus 3 equals to 20. I want to give the exact solution and an approximate solution accurate to 4 decimal places. My goal here is to isolate this x, to get it all by itself. And so it'll start off like a normal equation. The problem subtracts 3, so I can add 3 to both sides. So 17 e to the x is equal to 23. I can now divide both sides by 17. And so e to the x is equal to 23 over 17. That's not a nice round integer, so I'll just leave it in that improper fraction form. Now here's what I can do to solve for x. To get this x down from the exponent position, I can use the properties of logs. I can take the ln of this side, which means I take the ln of this side, and now I can bring this x down out front. So I have x ln of e equals to the ln of 23 over 17. Well, ln of e is just 1, and you can double check on the calculator. You can say ln of second divide, there's my e. That's e to what power is e, and that's 1. So these are gone. So x is equal to the ln of 23 over 17. And my approximate solution, 23 divided by 17 within those parentheses, is 0.3023. With that, I can move to number 12, a similar type of problem to solve with a little bit different take. It says solve the equation 6 to the 5x minus 2 equals 36. Give your answer to 4 decimal places. Now what I notice here is that the bases are 6 and 36. Well, I can make those very similar because 36 is the same as 6 squared. So now both of these are 6's, so it's like I can ignore those. If I can make these exponents equal, then I can solve the equation. So it's really 5x minus 2 is equal to 2. I can add 2 to both sides. So 5x is equal to 4. I can divide both sides by 5, and x is equal to that 4/5. On number 13, solving a log equation, I can use that log loop around. This is the same as 2 to the 4th equals to this 4x plus 5. So 2 to the 4th, be careful, it's not 8 if you check it on your calculator. 2 to the 4th is 16. So you want to solve 16 equals 4x plus 5. You can take away 5 on both sides. So 11 is equal to 4x. Divide both sides by 4. Since that's not a nice whole number and integer, I'll just leave that as 11/4. That's within my domain of logs. I'm not going to get any negative results there. And I'll work number 14 in a similar way after I combine my 2 logs into 1 log. So I've got the subtraction here between my 2 logs. I can make these a single log by dividing these. So it's really the log of x plus 5 in the numerator, x plus 2 in the denominator equals to this 1. There's no base written here, so it's understood to be a 10. And then I can use that same log loop around here. We're saying 10 to the 1 equals this x plus 5 over x plus 2. And this is my equation to solve. I can think about this as 10 over 1. So I've got a fraction on each side, and I can cross multiply. 10 times x plus 2 will give me 10x plus 20. 1 times x plus 5 is still x plus 5. I can take away an x on both sides. So I get 9x plus 20 is equal to 5. I can subtract 20 on both sides. So 9x is equal to negative 15. Divide both sides by 9. And while that is not a whole number, it will simplify to be negative 5/3. So I've got x is equal to that negative 5/3. Now, I am a little concerned about this as an answer because you can't have a negative in your logs domain. You can't have log of a negative number within this component of your log. So you need to make sure you're not going to get a negative there. So if I say negative 5 over 3 plus 5, that's going to be okay because that would give me a 3.33, and that's positive. I could say negative 5 over 3 plus 2 gives me a positive 0.333 over here. So no negatives. That's okay. X is equal to negative 5 over 3. This is not one of those rare D and E solutions. Moving on to our last page over here. On number 15, I'll do something similar to what I just did at number 14. I'll combine these into one log, so it's really log base 6. And I'm going to multiply these two components together, so it's going to be x squared minus 35x. Just x times this, multiplying those together. Still equal to my 2 out here. Now I'll use my log loop around, so it's 6 to the 2, or 6 squared, equals to x squared minus 35x. So 36 equals x squared minus 35x. And now I'm going to solve this. I'm expecting to get two solutions so far because the x squared. I'll move this 36 to the other side so I can have it equal to 0. Seems like this is going to factor, so x squared minus 35x minus 36. Switch sides and switch signs. And so I'll do my double set of parentheses. It has to be x and x to get that x squared. Lots of different ways to get 36. You've got 6 and 6. You've got 4 and 9. You've got 12 and 3. But if I want to get 35, well, I'm going to go with 1 and 36 because 1 times 36 is 36. And I can subtract those two and get a negative 35. If you say negative 1 plus 36, that would give you that negative 35. So this is what my 0 is equal to. And now I get two solutions from here. I get positive 1 from this one, and I get negative 36 from this. And while I get two solutions, the answer is really only the 1. Negative 36 is not really a solution because if you plug negative 36 back into your equations here, negative 36 minus 35 would give you a negative solution. Would also give you a negative right here, so that doesn't work. And in looking at this, it appears that 1 is also not a solution because 1 would give you a negative. When you plug it in there, you would get a negative 34. So ends up being no solution here. You can't have a negative within those logs here. All right, so we'll stop this video here and wrap up the last problem in our last video.